Good afternoon, ladies and gentlemen, and a warm welcome to our webinar, Grass, Milk and Robots. My name is Eva Ross, Marketing and PR Manager for Yara UK and Ireland, and I'm joined this afternoon by my colleague Philip Cosgrave, Yara's Grassland Agronomist, and Cormac Garvey, Farm Management Support Advisor with Lely Centre, Mullingar. Yara are delighted to be joining forces with Lely Centre, Mullingar for this webinar, where Cormac will take us through how the Lely robotic milking system works, different grazing systems for robotic milking, and grassland management for robotic systems. Philip will then discuss fertiliser applications this grazing season and meeting the herd's requirement for selenium when at grass. So before I hand over to Cormac, just to mention that this webinar is being recorded and we will have a Q&A session at the end of the presentations. So please submit any questions you may have and we'll go through them after Philip's slides. So Cormac, I'll hand the reins over to you now at this point.
Thanks, Eva. So my name is Cormac Garvey and I'm part of Lely Centre Mullingar's Farm Management Support Team, along with Sean Callan and Jordan Malloy. And just a quick overview, I suppose, of what we do as part of the Farm Management Support Team. So a big part of our job is when farms are getting set up, go out and walk the farm, look and see where paddocks, where's the best spot to set up paddocks, laneways, water, etc., just to make sure that the farm is set up as well as possible before the robot is installed at all. On startup, helping existing herds transition to robots and grass and helping new entrants get up and running. Continuous monitoring of farms following startup through calls, logins and visiting farms on a regular basis. Any adjustments or advice that might be needed throughout the year, based maybe on feeding, buffer feeding during the year or cow movement issues with that. And then just facilitating discussion group meetings so you can get out and about and see what other farmers are doing. So grazing for robotic milking. I'm going to give a quick overview today of the robotic milking process, grassland management for robotic systems, and grazing systems in a robotic scenario. So the robotic milking process. We'll start at the end. The last cow, feed trough moves out of the way and she walks out of the box. Back gate opens and the next cow walks in. So if you just look at the collar around her neck, that collar is unique to every cow. The robot identifies her and that she's due to be milked. You can see the feed trough has started to release feed to the cow. So this cow is being fed on a feed to yield system. Also, depending on how quickly or slowly the cow milks, the feed will be dispensed over the course of milking. So if it takes her 5 minutes to milk, feed will be dispensed over the course of 5 minutes. So following this, the arm moves in and the twin brushes start to clean the cow's teats. Along with cleaning the teats, this also stimulates milk letdown. Next, the arm moves again and in combination with the 3D camera and the laser attaches the cups. Between each milking, the brushes are washed with peracetic acid to kill bacteria. And this also reduces somatic cell count and mastitis. While we're talking about milk quality, this next bit of kit here measures the butter fat, protein and conductivity of the milk. Conductivity along with somatic cell reading for each cow greatly reduces the incidence of mastitis. So you can see here the front two cups are detached from the cow while the back two remain milking. This is because each quarter is milked individually, so this means no under milking, no over milking, as cups are detached based on milk flow from each individual quarter. Following this, teats are sprayed with teat tip and the cow can walk straight out of the box. Milk is then pumped from the collection jar to the milk tank. This can be up to 100 meters away, so there's no need for the robot room to be beside the milk tank. Between each cow then, the cups are cleaned. So in the video here, you can see it's being done with steam. In the majority of cases, this is done with cold water. Steam is just added extra. On the wall here, you can see the M for use buckets. So any cow in separation, her milk is going to each bucket. Each bucket contains milk from one individual cow, so that cow's milk can go to her calf. And looking here, you can just see the footprint of the robot. It's quite small, so it's very easy to fit the robot into an existing build, or on a new build. It means just less building costs. So grassland management for the ABC system. So there's 3 pillars of grassland management that lead to a successful robotic milking, robotic grazing system. And those are just farm walks, getting cows into the correct covers, and getting the correct graze outs. And together, these make for a successful robotic milking system. So farm walks. It's just important to get out, walk the farm regularly on a weekly basis, and know what covers you have. It's preferable to measure grass, and this of course will make it more accurate, no more the same as on a conventional system. However, this does not have to be done. There's only 20% of robotic farmers measuring grass regularly. The important thing is to know what the correct cover is and to know how much grass you have on farm and when you have too much grass, and this can be baled up and taken out of the rotation. So covers. Ideally, we want to have cows going into a cover of 12 to 1400. And the important thing to know is to know what the right cover is and just keep grazing this. And the biggest indicator of this, whether you're going into the right covers, will be the cows themselves. So 12 to 1400, it's leafy, high quality grass, and this will give maximum yield. And this in turn will also mean good cow movement. So again, the cow will be an indicator of whether your covers are right. If cows have been under allocated, they may be moving too often. If been over allocated, cows may not be leaving paddocks for you. So grass allocations. Grass is allocated on your ABC system at 40% in A, 40% in B, and 20% in the evening. There's less allocated in the evening just to help cows, aid cows' movement at night time. And this will be adjusted based on how cows grazed out paddocks the day before. And again, the important thing is just to know the right cover and keep grazing that. Here you can see cows, they were allocated the correct cover. They're happy to stay grazing. So if covers are too high, cows will move on. They might not want to clean out paddocks as well. Whereas here, they're happy to stay in the paddock. And the last few cows will stay grazing. So your ABC grazing system. This just consists of 3 8-hour blocks. It's the most common grazing system in Ireland. So just an example of an ABC layout here. You can see the A block on the top right hand corner. Cows enter this block at 2 AM. Following this, they'll move to the B block during the day. So from 10 o'clock in the morning, cows can go into the B block. And on the top left hand corner of the screen, you can see the C block. So just a few things to note then on this slide. The location of the roadways, they're central, very easy to graze off, and the location of waterways at the front of paddocks. On top of that, then you can see that we're strip grazing. So ideally we want to have 3 grazings per paddock. And then lastly, just there are cows in multiple blocks. So this is good, and it's an indication that grass has been allocated correctly. So benefits then of an ABC grazing system are higher milk output per robot. This is due to more even cow flow throughout the 24 hours. Increasing cow's intake of grass, so she's getting 3 fresh breaks of grass every day. And then it's also a benefit for heifers and lower ranked cows. They can access the robot at quieter times and then kick on to fresh grass. So yard location. This is often a question that my farm isn't suitable for a robotic milking system, that the grazing block isn't square, the yard isn't located centrally. But here's an example farm that we have. So the yard is located in the corner of the farm, and this isn't an issue at all. And the farthest walk on this farm is 1.4 kilometers. That's not an issue either. Cows, provided grass has been allocated correctly, will walk in and out. There's no issues there. So just this video here, you can see the majority of the herd. This is about 4 hours after gate change, and the majority of the herd has gone into the next block. For the last few animals, they're not in a rush to get up. They're just moving along at their own pace at their leisure up to the grazeway. And either they'll milk or just kick straight out to fresh grass. And just a few things to note in this video then is the location of water. It's close to the roadways. There are multiple access points into every paddock. and that the cows are being strip grazed. So just this video shows cows moving at gate change. So those first few cows there, they've been in advance of gate change, milked and kicked onto fresh grass. Again, this next group then have come in. Half of them go straight out to the grazeway and onto grass. They know that they don't need to be milked. The other few animals have gone into the shed, milked, and then moved out to the grazeway again and onto a fresh break of grass. If you look at these two animals coming up here, second animal tries the grazeway, but she's drafted to the right, so she is due to be milked, and she won't be let out until she has done so. So she'll make her way into the robot in her own time, and then back out to the grazeway and onto a fresh break. So it's important here that we wouldn't have more than 20% of cows at the grazeway waiting for a gate change. If there's any more than this, it's likely that grass has been under allocated in the previous block. So a question we're often asked then as well is, do cows milk at night time? And just looking at this video here, again, it's a bit sped up, but it's the 2 a.m. gate change. So the first group of cows, they came in advance of the gate change. They made sure they were milked. And then once the gate has changed, they can go out through, they're kicking onto fresh grass straight away. If you just notice the last few cows who come up to the gate, they're drafted back into the yard to the left. So they're due to be milked. They will have to milk before they can kick onto a fresh paddock. So in summary, just looking at your ABC system, it's not as complicated as you think. It's just important to make sure cows are grazing the right covers, that we're allocating correctly, and in turn achieving good graze outs, and just ensuring cows are not hungry, so grass is not being under allocated or over allocated in any paddock. So really, the same as with the traditional system, good grassland management will lead to better results. Robotic and traditional systems, they're very similar. And there will be significant experience and support at this stage with robotic systems, and advisors and farmers, if anyone wants to get out, get boots on the ground and see a system, just make contact with us. That can be arranged. So that's it, folks. Thanks for your attention. And if anyone has any questions, just make sure to put them into the chat box and we'll answer them at the end. And I'll hand you over to Philip now.
Thank you very much, Cormac, for going through that with us. And over the next 10 minutes, I'm going to discuss fertiliser recommendations on the grazing platform and also selenium intakes for dairy cows at grass. And I'd always like to start off with each presentation I do with just, a review just of how important soil pH is. And it kind of governs, a lot of the assumptions we make in the following slides with regards to the amount of grass we're growing. So if we keep our paddocks at the correct soil pH, between 6.2 and 6.5, we can optimize the applied nitrogen and phosphorus in particular. If we look at the offtakes of P and K, so what does the grazing platform require? And really it's a back calculation from what's actually being consumed by the cow and what's then being retained by the cow. So if we look at this particular table, the text in red is for the UK. So these are our oxide values. And then the first two columns where it just says P and K are in elemental form. So this would be for the Republic of Ireland, where we use elemental values for P and K. So for 1 ton of grass, dry matter, it contains 4 kgs of phosphorus and 30 kgs of potassium. We can see there, then if we convert that to phosphate for P2O5 and K2O, it's 9 kgs of P2O5 and 36 kgs of K2O. So then if we just multiply that up by, if we're growing, say, 14 ton of grass on the grazing platform, you can see how we get into larger numbers. And then if we assume then that 80% of that grass that's grown is going to be utilized, that slightly reduces it. So we're talking about 45 kgs of phosphate, but still a lot of potassium. and then if it works out at 101 kgs of P2O5 or 403 kgs of K2O. But that's what actually the cow is consuming. So roughly around about 40% of the phosphate that the cow consumes in of that grass will be retained by the cow for maintenance and also for production, so milk production, and 10% of the potassium will be retained. So if we kind of work that out, that can also be, I suppose, that's assumed that's our soil maintenance. So that's what the cow is taking off. So we need to replace that amount each year to make sure that we maintain that soil fertility, or that fertility that at any given point or time. So if we're at our optimum indexes, this is what we need to replace. This is the amount of P and K we need to replace to just keep them at that optimum index. So you can see there for P and K, it's 18 kgs and 34. Then for the UK, then it's the same value. It's 40 kgs of P2O5 per hectare and 40 kgs of K2O per hectare. Now, if we look at RB209, which we're basing the recommendations for P and K for grazing for the UK, we're recommended that we go on with 20 kgs of P2O5 per hectare and 0 kgs if we're at the optimum P and K index of 2. So as you can see, that's not going to be enough. If you have an intensive grazing system, what's going to happen in this case, if you're only replacing 20 kgs when you're taking off 40, obviously then your soil fertility is going to drop. And you can see particularly with potassium as well. So we definitely need, if we're looking at intensively grazed systems, we need to bump up the amount of P and K that we're applying to maintain and optimize grass growth on the platform. So if we look at, for the Republic of Ireland, the phosphate is regulated through the nitrates directive. So if we're looking at an intensively stocked farm at 2.5 to 3 livestock units per hectare, the requirement there is 19, you're allowed to apply 19 kgs of phosphorus per hectare. And then if we look at the amount of potassium that we apply isn't regulated, but if we look at Teagasc's Green Book, they would recommend then 40 kgs of potassium per hectare at those stocking rates. So if we want to, if you want to look at those values in units, you just multiply the kgs per hectare by 0.8 to give you units per acre. So what about the timing of this phosphorus, potassium and sulfur? Well, if we're trying to, just for maintenance applications, so if we're at our optimum index, and because roughly 2/3 of our total nitrogen applications are probably going to be on by the end of May, we're kind of front loading that P and K. And this is where, it makes sense, because at that period, we're actually growing a lot of our grass. So then obviously if we're growing a lot of grass, then there's going to be a high requirement for that P and K. So get your P's and K's out early, from March onwards. Now I have some recommendations later on in a slide later on, of using Yara products, but typically, if you're using nitrogen and sulfur for those first 2 applications in January or February and into March, then you should switch over to either the typical higher phosphate containing fertilizers, or you can alternatively go for your grazing grades to supply that P and K in that March-April period. But then don't forget about the P and K then during the summer months. If you look at the actual phosphate content of grass, it tends to drop in that end of May, June period, and at a time when cows are being bred, and phosphate is closely related to fertility. So if the cows are not getting enough phosphate intakes from the grass that they're consuming, well then they need to, they're going to run into problems. So by applying that phosphorus little and often, you're actually maintaining the phosphorus in your grass, which is beneficial for not just for milk production, but also for herd health and for fertility. With regards to sulfur, we're looking at applying on these intensive platforms. We're trying to grow a lot of grass. There's going to be a high requirement for sulfur, and it'll be required throughout the growing season. It's not just something in the early months or in midsummer. You really need to be applying sulfur throughout the grazing season. For build up, so if you're at suboptimal indexes for P and K, we would like to build up that, apply that extra P in March, you know, March, early April, or for that extra K, we're better off applying that requirement from August onwards. Because if we apply that extra K early on in the season, that can affect the uptake of magnesium because of that kind of luxury uptake of potassium in that springtime. So apply that extra K in the latter half, the later stages of the growing season, and there's no control, there's no restricted time for the application of potash. So we move on to a kind of just a general recommendation for an intensive system. You know, this is a UK recommendation taken from RV209. So on a farm producing 12 to 15 tons of grass dry matter per hectare, you're allowed, it suggests you apply 270 kgs of nitrogen, but you can see there by using NutriBooster, which is a nitrogen and sulfur product from Yara, go with that with the first application, but then that little and often approach then with a 25-5-5 with sulfur product, and that product Stock Booster S has also got selenium in it as well. So you're drip feeding that P and K throughout the growing season, and then, you know, finally then in that August-September period, you can go again then with NutriBooster. So we can see there that the actual total P, you know, you're applying your 270 kgs of N, but you're also getting enough phosphorus and potassium also to keep up your maintenance. For Ireland, for the Republic of Ireland, then if you're stocked at that 2.5 to 3 livestock units, you're permitted to use 250 kgs of nitrogen. And similarly, going with NutriBooster and then going with Super Booster, which is a grazing grade, it's 25, 2.5, 5 with sulfur, and there's also selenium in it. So that little and often approach throughout the grazing season, and that'll also deliver enough P and K anyway to maintain your P and K soil fertility. And when we're looking at the fertilizer we use, if we're using a blended fertilizer, you know, and there's only in this particular analysis, I've used the UK analysis, which is 27.55, but if for an Irish analysis, that same product will be 27.2.5. So if we're looking at a product like that, the phosphorus is in the form of DAP, a very concentrated phosphorus source. So there's actually very little of that actually in that product. So when that's applied, I'd say a typical at a 100-weight bag or 50 kg bags per acre, there's very few phosphate landing sites. Whereas if you use a complex compound fertilizer or a true uniform compound fertilizer, you know that there's phosphate in each granule or prill. So you get more landing sites, up to 10 times more landing sites for both phosphate, but also for potassium, which is going to benefit grass growth, particularly in those spring months. On phosphate, we know phosphate availability and is going to be compromised. Now, just switching to selenium intakes of dairy cows at grass. What we have is that as we go into April and May, supplement feeding is reduced, so there can be a deficit there for selenium intakes in cows. So it's an essential trace element for cows. You know, selenium and vitamin E have complementary but independent roles. And I suppose, their particular function is that they have an antioxidative effect in cells, and that then has an impact then on the immune function of cows and other livestock. So low selenium status is associated with higher somatic cell counts and also higher mastitis rates and lower herd fertility. So this particular study in France looked at low selenium status herds and comparing low selenium status herds with good selenium status. But they found typically, you know, we associate selenium with abortion and also retained placentas at calving. But they found in that particular study that herds with low selenium status were likely to suffer from at 2.5 times more likely to suffer from low fertility than herds with adequate selenium intakes. So what dairy cows require, we generally look at, you know, what a dairy cow requires by way of any of the trace elements by what they need in per kg of dry matter intake. So dairy cows require 0.3 milligrams of kg of selenium per dry matter intake. So grass typically contains less than 0.05 milligrams per kg. So, you know, you're looking at 6 times less than the required amount. So if you extrapolate that up, 15 kgs of grass dry matter, if you're allowing 15 kgs in the diet on a daily basis, so you've cows getting about 0.7 milligrams of selenium. Now, 50% of that is going to be absorbed. The other 50% will be excreted in the feces. And then if we look at a cow producing 25 litres will, that 25 litres will contain 0.9 milligrams of selenium. So you can see there how quite easily the cow can drop into a negative selenium status. And there is storage. The cow can withstand those negative selenium balance for a short while, but after a certain period of time, then stores will be used up, and then that's when the problems occur. Now we're looking at selenium supplements, so inorganic selenium supplements in boluses and also in mineral mixes. And in licks, usually they're inorganic selenium in the form of sodium selenite. But if we look at NRC guidelines, they're typically the absorption rates of these particular inorganic supplements around about 30%. So that's bare minimum. So if we can get more selenium into the grass, then there's higher absorption rates. It can be used more effectively. So this is just a survey done, carried out by Chagas back in the late 80s and 90s, where they looked at the selenium levels in grass samples that were submitted to Johnstown Castle. So 76% of the grass samples that were submitted were low in selenium. And through the Yara lab in Yorkshire, there's over 70% of the grass and silage samples that go through that lab are actually deficient, have got levels of below 0.05 milligrams per kg of selenium in them. So it's a real problem for grass having low selenium issues. So how can we effectively get more grass? You know, a safe and effective way of increasing the selenium intakes for cows, for dairy cows at grass. So if we use fertilizer that's fortified with selenium, we apply that on grass that's got low selenium levels, and that can then, if we use that throughout the growing season, we can effectively increase the selenium levels in the grass to over 0.1 milligrams per kg dry matter. So if we're using it constantly, we see actually that the selenium contents in that grass can be up to be, you know, at the desired range of 0.2 to 0.3 milligrams per kg dry matter, which the actual dairy cow requires. And my final slide is just Yara's product, that Yara's booster range is, there's 3 products in it, and each one of those products has got selenium added at the same rate. So there's there's 15 parts per million or 0.0015 inclusion rate of selenium in those products. And the type of selenium we use is sodium selenate. You know, Yara have been fortifying fertilizer with selenium since the mid 80s. And that started off in Finland, and they were found that sodium selenate was the most effective form of selenium to add to the fertilizer. So it was the most efficient at going from the fertilizer, applying it into, and that was basically onto the soil, and then the actual roots then, grass roots could then take that selenium up very efficiently. So we're on the trials that we've done in Ireland, where these products have been applied, you know, after cows have come off from grazing paddocks. Basically, again, the cows go back in between 20 and 21 days later. The actual selenium levels in that grass have been elevated to above 0.1 milligrams. So that's increasing the selenium levels in the grass 6-fold in that short period. So with that in mind, I'd like to hand you back now to Eva, and thank you very much.
Great. Many thanks, Philip and Cormac, for your presentations there. Philip, a couple of timely messages from yourself there regarding selenium and phosphorus as we head into the breeding season, with phosphorus being important not only for grass growth, but also for cow health, and cows with the low selenium status are 2.5 times more likely to suffer with low fertility. And Cormac, you mentioned that ideal cover is to turn cows into our 12 to 1400 kilograms of dry matter per hectare, and for our colleagues in the UK, this cover would equate to 2,700 to 2,900 kilograms of dry matter. So at this point, we'll crack on with our Q&A session. We've had a number of questions in, which are great. And Cormac, I'm going to ask you to answer our first question there. How much more time is spent managing grass on robots, 3 grazing blocks instead of 1 on a parlour? Oh, Cormac, I think you're on mute there. Lovely.
Okay, so I suppose to start with, anyone who's doing a good job of grazing management, whether they're in a parlour or on a robotic system, you'd expect them to be out walking the farm maybe on a weekly basis. So we'll put that aside. Once the farm is set up correctly, you're looking at moving 3 strip wires really as opposed to 1. So I think John Shorehall in Chagas did studies on this. He found about 20 minutes longer on in a robotic scenario as opposed to a conventional system. So just 20 minutes really is the answer then.
20 minutes, thanks Cormac. And a question for you here, Philip. With breeding getting close, should we split fertiliser into weekly spreads instead of blanket spreading?
I think blanket spreading is carried out as a way of you know, a labour saving initiative. But yeah, the preference is to apply fertiliser within a couple of days of cows coming off paddocks, and that is found to I suppose be beneficial in that you utilize the nitrogen in that fertilizer more better, in that I suppose grass generally tends to first of all, it takes up the fertilizer and then it accumulates that nitrogen that is taken up then into actual biomass or grass growth. But obviously on certain paddocks that have you know been that are going to be grazed quite quickly, you know, in a blanket spreading scenario, you can get elevated levels of nitrate in that grass, and then obviously then that will come through into the animal cow will graze that, and basically that nitrate then will elevate the nitrogen in the urine and also feces, but then there's actually going to be a greater chance of that nitrogen in the urine being lost or being volatilized as ammonia. So you're losing nitrogen out of the system. So wherever possible, we should be following the cows with fertilizer, maybe not necessarily, but maybe grouping a number of paddocks together and then spreading them at the one time, maybe rather than blanket spreading all your paddocks at the one time.
Great, thanks Philip. And Cormac, a question for you here on zero grazing. Will I need to zero graze or feed silage inside if I milk with robots?
I suppose that comes down to the size of your grazing platform really. If you have a small grazing platform, there are numerous farms here in the centre in Mullingar where they're grazing AB outside and zero grazing grass or putting silage in for C for the 3rd block. That really comes down to the size of the grazing platform. If your grazing block is big enough and your grass growth is above your demand for feed, there's no need to. There's a lot of farms then they might be zero grazing with saying buffer feeding during drought or else just in the shoulders of the season. But as a rule, no.
No, okay, thanks Cormac. And another question for you here, Cormac, why not use AB, the AB system?
As opposed to the ABC? Well, yeah, AB would be a simpler system. You'd be just have 2 12-hour blocks. It'd be a cheaper system. You'd have 1 less roadway. However, your heifers and your lower rank cows, they probably suffer on that system a bit. They wouldn't get access to fresh grass as often. I suppose you get better utilization of grass off an ABC system as well, and better milk output through the robot. Cows will be coming in to get 3 fresh breaks as opposed to 2.
So good reasons behind that ABC system, Cormac. And then question here, if I don't measure grass, how do I know what requirement for P and K I have? Philip, if I could ask you to answer that one.
Yeah, generally what I suppose if you're feeding very little, if you're feeding kind of moderate levels.
Philip, you've got a PA there by the sound of it.
Excuse me, but if you have obviously you're growing a lot of grass intensively, an intensive grazing stock grazing platform, and feeding very little concentrate, then it's likely you're going to be growing those higher levels of grass. But it's just a matter of I suppose bearing in mind that watching soil analysis and making sure that your soil analysis is, you're doing it every 2 to 3 years. And then that will have a feedback, that will feed back into watching your P and K indices, that they're not falling or they're not going too high either. So that's definitely, it is a question that I'm often asked, like, but you're getting down into, it's just, I suppose the slides that I have there were just kind of an indication of the likely offtakes where you're growing a lot of grass. Now, not everyone is going to be in a position maybe to know exactly how much grass they're growing, but you'd have a fair idea that if you're if you're intensively stocked in that grazing platform, and you're using, up around about that 250 kgs of mineral nitrogen, it's likely that you're, somewhere over that kind of 12 to 14 tons of grass grown. So, but soil analysis and then watching and recording what you're applying, so then that what you've applied over the last couple of years, and then with that looking at the soil analysis at whether your soil indices have dropped or increased, and that's a way of kind of correcting whether you're over applying something or under applying P's and K's.
Great, thanks. I'm going to stick with you now for a couple more questions here, Philip. This is on concentrate feed, this next one. Will the amount of concentrate I feed cows influence what phosphorus I can spread?
That's a good question. It's something I didn't cover during the slides. There is an adjustment in the Republic of Ireland. There is an adjustment there for the amount of mineral phosphorus you can apply, and generally, if you're feeding, if you're feeding 2 ton of concentrate per hectare, well then you should reduce your mineral P by 6 kgs per hectare. So I think I put up there 19 kgs. So basically that would reduce, if you were feeding that 2 tons of concentrate per hectare at that 2.5 to 3 livestock units per hectare, well then that would bring the P allocation, mineral P allocation, down to about 12 kgs of phosphate per hectare. So obviously there's around about 5 kgs of elemental P in every ton of concentrate, or in UK analysis you're talking about maybe 12 to 13 kgs of P2O5 in every ton of concentrate that's being fed. So that's obviously going to add to your reserves as well.
Great, thanks, Philip. And this next question came in from a farmer who started breeding last week. Could selenium injections or boluses be used instead of fertilizer for a quick bit now? Philip, if I could ask you to answer that one.
Yeah, certainly. That can be, boluses can be used, and they're very effective. And it's, it is between the application of that mineral selenium in the fertilizer and when it gets through to that grass, you are talking about maybe 3 weeks. So if breeding is, if you're looking at making sure that your cows have adequate selenium, well then giving boluses now will be a good way to ensure that your cows have that selenium in the coming weeks. But I must add that it's important that we don't over supply selenium. So that particular, the person who posed that particular question, it's important then to look and see that you're not over supplying selenium in the diet. So whether it's through boluses or whether it's through what's the selenium maybe in a concentrate and the supplement that's being fed, they will all need to be taken into account as well.
And Philip, another question on selenium here. Will silage selenium levels increase if I use a selenium fortified fertilizer on my silage ground?
You might see now there's a little head popping up and down here now. So this person is trying to get involved in this webinar as well. But pretty much it's a question I'm often asked about, using one of the Yara, say like a Yara booster product on silage ground, you know, silage, because selenium is a mineral, it doesn't degrade. It's not like one of the vitamins that you know, and that, say for vitamin E, for example, that in silage. So fresh grass has very high levels of vitamin E, but vitamin E levels then in preserved grass as silage, the vitamin E levels actually drop because it degrades over time in those acid conditions. But for something like selenium, the selenium, you know, will stay in the grass, and it's still available. And yes, if you apply any of those Yara booster products on silage ground, well then yeah, it will elevate the selenium levels, and that will have a positive effect on your herd's intakes then come feed out.
Great, thanks, Philip. And Cormac, I have a question for you here just regards yard location. Cormac said the yard doesn't have to be in the middle. How far can cows walk before going too far?
Yes, so I suppose from experience here in Mullingar, there are farms walking up to 1.8, 1.9 kilometres, and some of them over quite hilly terrain. And once grass is allocated correctly, there's no issue with that. Now, you will be maybe balancing those further walks up with having the next break closer, so maybe only 500 metres away, but 1.8, 1.9 kilometres, there's no issue with all of that.
That's great, Cormac. And I think, have we got a hand up here to ask a question? If we can facilitate that. Maybe not. Okay. Philip, I'm going to get back to you to answer a question, and then we'll get to Heather. Heather has her hand raised there for a question. So Philip, I'll just ask you to answer this next question before we go over to Heather. And it relates, there's two questions in there relating to soil sampling and sampling NPK. I only ever soil sample for NPK, pH. Should I test for minerals, and how often? And then question that ties in with that as well, how often do you recommend soil analyzing, and what other factors can affect NPK levels?
Well, we'd recommend pretty much, it depends. There's obviously in some jurisdictions you'll be obliged to test with a certain frequency, but yeah, pretty much you know, 3 years is a good period for which to to test your soils for P and K. Now, I think nitrogen was mentioned there, N, P and K, but really we're looking at phosphorus, potassium and soil pH. So yeah, 3 years up to 5 years, but a lot can happen if you're growing a lot of grass, and particularly, you know, if there's maybe silage being removed from certain paddocks on a grazing platform. Your soil P's and K's can get out of kilter very, very easily. So don't leave it too long. I think that, you know, kind of 2 to 3 years is probably the best target for which to test your soils. I guess for what the other types of, you know, what else can you test for? What's you know, on a livestock farm, I would tend to myself, instead of maybe the micronutrients or the trace elements, I think at times you're better off looking at those levels in actually getting grass tissue samples sent to the lab rather than soil samples, because I think the grass tissue samples are actually what the actual animals are eating. So for example, if you get a soil sample and you test it for selenium, well, it'll give you an indication of what your selenium levels are like. But if you were to give that to your nutritionist to work out whether you need to supplement more or less your selenium, then he or she won't have the information at hand. So, but if you provide that nutritionist with herbage analysis, you know, they'll know exactly how much selenium or zinc or copper that those animals are getting from that grazed grass or silage, for that matter. And I think, is that the questions answered, Eva?
Yep, no, that's great, Philip. And question here, what form of selenium should I ask for if other fertilizers have selenium blended into the product? So I suppose, yeah, I suppose no harm to just to mention as regards the CCF product versus blended, Philip.
Well, I can only speak for the Yara product, and that we have we include sodium selenate in our product. So yeah, I'm not. Yeah, I suppose it's a question to ask about what the type of selenium that's been added, and in what form. And I guess in you know how it's actually, you know, the physical nature of how that selenium, whether it's if it's in a blended product, whether it's as a powder or whether it's as a coating. I suppose with the Yara product, it's in each granule because it's a CCF or true uniform compound. So you know that selenium is actually contained within that granule. But for other products with selenium in it, it's very much, you know, you ask them the questions, because obviously the way the selenium is added to fertilizer will dictate, you know, how evenly it can be applied.
That's great, Philip. And then one final question here relating to CAN and sulfur. And Philip, I'll ask you to answer this one, and then we'll wrap up the session then. Would CAN with sulfur blend not be good enough for second cut silage?
Well, that question, I suppose, included the word blend. But if we just take the two nutrients, you know, CAN as in being nitrogen and sulfur, it would really depend on what the soils require, like whether there was, if there hasn't been a soil analysis carried out recently, then I would tend to go for an NPKS product. You know, and that might be if, you know, if the ground has been regularly receives, you know, slurry or organic manures, then maybe the P's and K's may be okay. But I wouldn't really, you know, I would only kind of recommend that nitrogen and sulfur only where soil P and K is adequate, or where it's adequate and it has received organic manures to supply that P and K.
Great, thanks, Philip. And yeah, folks, that wraps up today's webinar. We do have another session at 7 o'clock this evening. So if you have colleagues or that would like to join, please pass on the registration link to it. Many thanks to Philip and to Cormac for their time and input into today's session. And special word of thanks to our colleagues in Yara and also at Lely Centre Mullingar, all the backroom teams there that have ensured a smooth running of this afternoon's event. But most of all, many thanks to you, our audience, for joining today and for asking those questions. It always makes for a good interactive session when we've got the questions. So we leave it there, and hopefully we will be online again for further webinars. So take care, everybody.